Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 23, True and False Number Sentences. So we're going to look at equality and inequality symbols, including the following. Equal sign, which hopefully we pretty much know what that is, less than, greater than, and now we're going to add a couple, less than or equal to, greater than or equal to. And so we'll kind of talk about what that is. We're also going to look at a number sentence and decide if it is true or false based on the symbol, which are these 5, that you're given. So let's jump right into it and check it out. First thing we're going to briefly talk about is the equal sign. A lot of people, everyone knows what the equal sign means. They mean, well, like 2 plus 2. That's a goofy looking plus sign. Let's fix that. 2 plus 2 is equal to 4, which is true. But another way to think about it, especially as we move into what we're going to be doing now, is just to know that the equal sign basically just says what's on this side is the same as what's on this side. So if we have 2 plus 2 equals 5, 2 plus 2 equals 4 is a true number sentence. 2 plus 2 equals 5 is a false number sentence. It's not true, right? Because this side does not equal this side. They're not the same thing. So equal means equal to. That means they're both sides are the same. You could also look and see that 4 and 7/8 is equal to 4.875. If you divided 7 and 8, you'd get 0.875 and then your whole number. So even though this is a fraction and this is a decimal, this is the same thing as this, so they are equal. Okay, this symbol is the greater than symbol, right? So you say, well, 5 is greater than 4. That's true. What is on this side is bigger than what's on this side. If you said 3 is greater than 10, that's false. That's not true. What's on this side is not greater than 10. Okay? So you could say 5 and 1/4 is greater than 4 and 7/8. That's true, because 5 and 1/4 is a little bit more than 5. 4 and 7/8 is just barely a little bit less than 5. So this symbol saying that 5 and 1/4 is greater makes that a true number sentence. Okay, this is the less than symbol. A lot of people, including myself, kind of remember that by saying it almost looks like an L for less than, right? It's kind of an easy way to remember that. Okay, I totally just paused that, and I don't know how long ago I paused it, so I think I must have just hit it. But anyway, 5 is less than 2. That is false. It's not true. 4.5 is less than 4 and 7/8. That is true, right? The 4s are the same, but then 1/2 is smaller than 7/8. 1/2 is half of 1. 7/8 is almost a whole number, a whole 1, right? All right, now let's get into a couple of new symbols here. This looks like the less than symbol, right? And it is. But if I add a line directly underneath it, it means is less than or equal to. Okay? Now the examples we're going to use today are not going to make total sense, and I'll explain why, but learning this symbol is going to be really important because we're going to use it a lot going forward. So if we say, remember, less than or equal to, if we say 5 is less than or equal to 5, is that true? It is true, right? Because it says or equal to. That's what that line means. So it is equal to 5. So 5 is less than or equal to 5. Yeah, it's equal to, right? If we said 5 is less than or equal to 6, that's also true, because it is less than or equal to. It's not both, but it's one of the two. It's less than. If we say 4 and 7/8 is less than or equal to 4 and 7/8, once again, that's true. It's not less than 4 and 7/8, it is 4 and 7/8, so it's less than or equal to. If we said 5 is less than or equal to 2, then that would be false, because 5 is not less than 2, 5 is not equal to 2, so that would not be a true statement. Going the other way now, that looks like the greater than symbol. You put a line underneath it, and it means greater than or equal to. Same thing as less than or equal to, except it's going the other way, right? So we could say 5 1/4 is greater than or equal to 4 7/8 because it is greater, right? It's one of the two. It's either greater or equal. We could say 3 is greater than or equal to 3. It is true because it's not greater than, but it is equal. It's one of the two. We could not say 2 is greater than or equal to 3. That would be a false number sentence because 2 is not greater than 3 and it's not equal to 3. So now I'm going to give you a couple of problems, and I'm going to actually give you the, we're going to write an inequality or an equation, and then we're going to make x equals 3. So in each of these examples, x is going to equal 3. So I'm going to say 5 plus x equals 8. Is this true or false? Well, if we say x equals 3, we're really going to say 5 plus 3 equals 8. That gives us 8 equals 8. So it is true. 5 plus x, or 5 plus 3, is 8. There's 8 on the other side. That is true. What if we say 5 plus x is greater than 8? Well, once again, we know that x equals 3. So we're going to take the x out. We're going to put 3 in. 5 plus 3 is 8. Is 8 greater than 8? No, that is false. That it should say 8 is equal to 8. Now, what can we do to make this statement true? That's a false statement, but what can we do to make this statement true? We could say 5 plus 3 is greater than or equal to 8, and now we have, wrong one. Now we have a true statement, because while it may not be greater than, it is equal to. 5 plus 3 is 8, it's equal to 8, obviously. Essentially, we're going to do a couple of examples here. Essentially, as we look at the examples today, you're going to be given a number sentence. You're also going to be given a variable, and you're going to have to decide if that variable, the value of the variable, makes that a true or false number sentence. All right? Okay, so let's look at 4 plus x equals 12. We're going to say x equals 8. So, if x equals 8, I'm going to change the x in the problem to 8. 4 plus 8 is 12. That is equal to 12. We have ourselves a true number sentence. All right, let's try another one. 3g is greater than 15. We're going to say g equals 4 1/2. Well, if we then substitute, take out the g, and we add in 4 1/2, we can then solve, and we know, okay, well, 3 is basically 3 over 1. We're going to multiply, we're going to use our MAD, right? Multiply, add, denominator stays the same. 2 times 4 is 8. 8 plus 1 is 9. 9, denominator stays the same. 9 times 3 is 27. 1 times 2 is 2. 27 divided by 2 would give us 13.5 or 13.5. So this equals 13.5. Is that greater than 15? It is not. It is false. So what would make this true? What would make, let me clean this up a little bit. What would make 3 times g is greater than 15? What would make that true? Could we put a 4 in for g? 3 times 4 is 12. Nope, that's not greater than 15. Could we put a 5 in for g? 3 times 5 is equal to 15, so it's not greater than 15. So it would have to be anything greater than 5. Any number that you picked greater than 5. 5.1, 6, 25. Any number bigger than 5 would make this statement true. Let's do just a couple other ones here. We'll say 18 is less than or equal to 32 minus b. b is going to equal 14. Okay, so 32 minus 14 equals 18. So 18 is less than or equal to, well, it's not less than, but it is equal to. So this is a true statement. Essentially, you have to look at what your symbols are. You have to solve for the variable and then decide, is this true? Is this not true? What could I do to make it true? Okay, we're going to stop there. We'll do several more examples together in class and check these out, give you a chance to practice on these kind of problems. Thank you for watching. Thanks for listening. We'll talk soon. Thank you.